graphs of polar equations. All right, if we want to graph something like they've given us here, r is equal to 3 plus 2 cosine theta, we're going to use our polar paper. There are several pages of this in your packet, but if you need more, you could always go print some online. The values around this polar paper are just the same values as we had on the unit circle, and so that's what I'm going to choose to put in my table as I build this table of values. So if I take 0 and I plug it in the place of theta in this formula, that would give me 3 plus 2 cosine 0. Cosine 0 is 1, so 2 times 1 would give us 2, and 3 plus 2 would give us 5. Be sure that you practice putting several of these in your calculator as we do these first few, and make sure you're coming up with the right answer. If you're not getting that answer, let me know and I'll come look at it with you. All right, so next one, let's plug in pi over 6. So if I put pi over 6 in the place of theta, cosine at pi over 6 is square root of 3 over 2. Multiply that by 2 and we'll get 3 plus the square root of 3, which is 4.7. And again, when you put this whole string in your calculator, you should be getting 4.7. All right, then try plugging in pi over 4. When you plug in pi over 4, you should get 4.4. Anybody having trouble getting those values on your calculator? Okay, then once you've tried a couple of them and you know that you can come up with those values correctly, then go ahead and just fill in the rest of the values from the table. There's no need to sit here and plug 15 different values in. You will notice that sometimes when you're plugging these values in, you'll start to see some symmetry. Like when I plug in 7 pi over 6, I get the same answer as what I just got for 5 pi over 6. When I plug in 5 pi over 4, same thing I just got for 3 pi over 4. That's because if you think about sine and cosine, it's the same values around the unit circle. The signs change to positives and negatives and that type of thing, but a lot of times you will have symmetry for that reason. All right, so once we've built our table of values, then let's go plot these points, and this gives us great practice with what we were doing yesterday with plotting the polar points as well. So for the first one, 5, 0, I'm going to go to 0 radians, and I'm going to go out a length of 5. Now, on the polar paper, I've got 10 concentric circles, so since I have the largest value in my table being 5, I'm going to count by halves, but you could count by ones or whatever you wanted to. So I'm going to go to 0 radians and go out a length of 5. All right, then I'm going to go up to pi over 6. And because we've built our table to literally just be the lines from the polar graph paper, I don't really have to think about it. I can just say, okay, next line, go out to 4.7. Next line, go out to 4.4. So if I have 4 right here, 4.5, 5 right here, 4.7 just in between. Next line is 4.4. And as I get a couple of points here, I'm going to start connecting them because I don't want to end up with 20 points on my graph and then I don't know which order to put them in, so I can just kind of connect them after I get a couple. So pi over 4, I'm going to go to my pi over 4 line. Again, that's just the next line, and go out a length of 4.4. Next line, 4, so pi over 3. Next line, 3, so I'm going out a radius of 3 on the pi over 2 line. Next line, 2 at 2 pi over 3. Next line, 1.6 at 3 pi over 4. 1.3 at 5 pi over 6. 1 at pi. So there's half of my figure. All right, then 7 pi over 6 going back out to 1.3. Next line, 1.6. Next line, 2. Next line, 3. Next line, 4. Next line, 4.4. Next line, 4.7. Next line, 5. And so when I finish, looks like a little heart. Now, this is not a really exciting graph, but if you'll notice in your textbook on page 750, they show you that you could create some more intricate graphs. You could make some flowers and hearts and circles and infinity symbols and that type of thing. The more elaborate your equation, the more elaborate your graph is going to be. Like if you look at the bottom page 748, you can make a cute little butterfly, but that's a pretty nasty equation down there for me to be, plugging 15 different points into and evaluating. So yes, I can get more intricate graphs, but I also have more intricate equations with that. All right, look at the next one. For the next one, we've got r is equal to 2 cosine 3 theta. Now, I need to be careful how I put this in my calculator. Like, when I put in the first value of 0, I take 3 times 0 first before I take the cosine of that product. And then whatever I get for my cosine value, then I'm going to multiply that by 2. So again, as you're putting this in your calculator, be sure you're practicing the keystrokes that are necessary to get these values. Next one, pi over 6. So I'm going to have to do pi over 6 times 3 first and get pi over 2 before I take the cosine. Then cosine pi over 2 is 0, and 2 times 0 would be 0. So again, try putting the first maybe 2 or 3 or 4 of these in your calculator and make sure that you're getting the correct values. If you're having any trouble, let me know and I'll come look at it with you. And then once you've got those first couple of values working correctly in your scientific calculator, then just go ahead and fill in the rest of the values from the table. All right, so let's look at how we can plot these points. Now, the largest value that I have is 2 or negative 2. So I actually could count by fourths or something else if I wanted to. I'm going to count by halves exactly like I did on the last example, so I don't confuse anyone when you're looking back at this. I'll have the same scale on all of mine, but you could set your scale to be what you want. All right, so for the first one, we have 2 zeros, so we're going to go to 0 radians and go out a radius of 2. Then we have 0 pi over 6. So when I get to pi over 6, I go back to 0. I'm just not really sure how to connect those. Like, typically we don't connect with a straight line when we're working with sine and cosine. It's a curve. And so anytime I need more information, I'm welcome to plot another point. The points that we have on the polar paper are just a guide. But I definitely could go back and say, hey, I need more information in between 0 and pi over 6. So I'm going to go halfway in between and plug in pi over 12. So I could just add another value in my table anywhere I needed to. So when I plug in pi over 12, either by hand or with my calculator, I'm going to get 1.4. So we can just insert that value in our table up here and say, okay, now let's come over here and plot that point. So once I plot, here's pi over 12. If I come out 1/2, 1.4, because 1.5 is about right here, now I know exactly what that graph should look like. I'm going to start, here's my first point, here was my second point, here's my third point. And just as we thought, when you're graphing sine or cosine and you go from 0 to 1, I don't go in a straight line, I go in a curve. And that's going to be the case with these graphs as well. Seldom will we use a straight line, we almost always will be using a curve. So now I have a feel for what that looks like. I can keep going with my next point. All right, next one is pi over 4 negative 1.4. So remember that a positive radius is going to go this direction. A negative radius then is going to go on that same line but in the opposite direction. So all I have to do is say if positive 1.4 would have gone this way, stay on that same line and go the opposite way. Negative 1.4 would be 1/2, 1.4. All right, then pi over 3 negative 2. Same idea. A positive 2 would have gone this way. So a negative 2 is just going to go the opposite way. So negative 1/2, negative 1, negative 1.5, negative 2. And again, as I'm coming around here, you can see that continuing that curved shape. So when I get to the next value, which is pi over 2, 0, I know from this point that I just plotted, I've got to come back to 0. I know I'm not going to come straight back. And if I follow this same kind of shape, I have an idea it's going to kind of loop around. But I could always give myself another point. So if I wanted another value in here to be a guide to go back, all I would need to do is plug in another value between pi over 3 and pi over 2. So I could just pick another point in there and plot it, and that would fill in this gap if I needed some more direction. All right, so then the next value that we have, 2 pi over 3 positive 2. And then the next one, for my next line, we're going to go out 1.4 at 3 pi over 4. Next line, we're going to go back to 0 for 5 pi over 6. Next line, we're going to go to negative 2 at pi. So if the positive 2 would go this direction, then the negative 2 is going to go in the opposite direction. So I was at 0, and I want to go around to negative 2. All right, then I go to my next value. So 0, 7 pi over 6. So again, remember I'm right here, and I want to come back to 0. And then next line, 5 pi over 4, 1.4 is where I'm going for my radius on that line. Next line, I'm going to go out 2 at 4.3. Next line, I'm going to go back to 0 at 3 pi over 2. And I start to notice that, hey, I'm just graphing on top of that graph that I already had. And sure enough, if I graph that whole second column, that second column just graphs right on top of that first column of values. There are sometimes, like in our first example, you have to go from 0 to 2 pi to get your whole graph. There are other times, as in this example, we only needed to go from 0 to 1 pi to get your graph. Sometimes you might have to go from 0 to 4 pi to see your whole graph. But when they start repeating, then you'll know that you're finished. Now, it is possible to graph these polar graphs on our calculator. So grab your graphing calculator if you would. You need to make sure that you are in radian mode, and you want to switch your calculator from function mode to polar mode. So hit your mode button and switch from function to polar. So just scroll over to polar and hit enter. All right, I'm going to put in that equation that we were just working with. When I go to y equals, it's no longer going to say y equals. Now it's going to say r equals. So we've got r is equal to 2 cosine 3 theta. And if you're wondering where I got that theta, when you're in polar mode and you hit your X button, it'll put a theta on instead of an X. So 2 cosine 3 theta. I also want to set my window. Now, when we were graphing 2 cosine 3 theta, we set our table to go from 0 to 2 pi. So I can tell my calculator the same thing. For the theta values, I want you to start by plugging in 0, and I want you to stop by plugging in 2 pi. So when I hit 2 pi enter, it'll switch it to this decimal. You can count by whatever you want to. Tell it to count by 0.1, or tell it to count by pi over 6, or whatever. Again, it's going to convert whatever you type in a radian mode, like with a pi in it, it'll convert that to a decimal. Then I can just set x and y as I normally would. So I've got my x's going out to about 4.5, and I've got my y's going out to about 3. So you can set your x and y values to whatever you'd like. So when I'll put my equation in and hit graph, you'll notice that it's only going to take it about 15 seconds to graph that exact same thing that we just spent 5 or 10 minutes graphing. If I have my graphing calculator, then maybe that butterfly wouldn't be so hard to graph. So I'm going to go back into r equals, and I'm going to put in that equation that we saw on the bottom of page 748, and then sure enough, I can get my calculator to graph that butterfly as well.